Hey there, welcome to a video discussing pages 3, 4, and 5 of the section 4.1 notes. So we discussed chain rule, and we're going to go over some more advanced problems regarding chain rule. So I'm just going to pull up my filled out notes on my other device so I can make sure I get the problem done right. So example 7 is quite complex. We want to do take derivative x5, which of course is 5x4, because you're going to do a product rule here. So again, I took derivative of x5 is 5x4 times 7 minus 2x raised to the 6th power. Leave that intact. Plus x to the 5th power. And then I'm going to have to do the chain rule with 7 minus 2x raised to the 6th power. So again, it's y prime. So y prime equals 5x4 times 7 minus 2x raised to the 6th power plus, and then if you work this out, that's going to be x to the 5th times, that's going to be 6, 7 minus 2x raised to the 5th power, then times -2 on the inside. Yep, I got that right. Then, of course, y prime will be all this junk here. 5x4 times 7 minus 2x raised to the 6th power plus, actually we'll do a minus 12x to the 5th, 7 minus 2x to the 5th power. And if you so desire, you can actually clean up just a tad more. You're fine at this point. But if you clean up a tad more, you could actually factor out an x4 and a 7 minus 2x to the 5th power. And then you have 5, or 5 times 7 minus 2x minus 12x. And that should be fine if you left it like that too. Or you can clean up the inside here and get 35 minus 22x. And you can always check your work. Remember, if I go to the TI-84 calculator, TI Smart View, here we go. It's taking a sweet little time. No, I don't want to do that. Okay, and let me close that down. Close that down. Clear. Okay. So I'm going to type in the function, which was x to the 5th times 7 minus 2x raised to the 6th power. And what I found by hand was x to the 4, 7 minus 2x, oh, yikes, x to the 4, 7 minus 2x raised to the 5th power negative 22x plus 35. The graph. Actually, let me turn off the first one. Let's try it again. Okay, and if you hit the trace button and hit the down key, you're on the same graph. So you know we've done this correctly. It might come back down eventually. I mean, these numbers are really, really large. Yeah, we kind of bypassed it, but if you hit the down key, you're on the same up key, down key, he's changing the functions, you're in the same place. So we know we've done this right. Okay. And why did I close that? That was not smart. Let me reopen it again. Where is it? 4.1 notes. Oh, geez, got a lot of files here. There we go. Okay. So we keep moving. Let's look at a rate. So here we have a composite of 3 functions. Kind of crazy, right? So you have an inside. So you have like, that's your outside. That's your inside. And that's like your inside, if you want to kind of call it that, right? So y prime is going to be, take derivative of sine, which is cosine, and leave the entire inside intact, times, I'll change colors here, the derivative of cosine x squared minus pi. Then, when you keep writing your derivative, cosine, remember we kept that intact. So the derivative of that's going to be negative sine of x squared minus pi times that derivative. So because you're doing the chain rule again. So it's a double chain rule. And I'll put the final answer in black. So y prime will be cosine of x squared minus pi. And that will be negative sine x squared minus pi times 2x, because root of pi is 0 because it's a constant. And you can leave your answer like that, or you can move the negative and the 2x off to the left if you like. Doesn't really matter to me. But at that point, your answer's done. So that's why I might put in our quiz something a little more advanced like that, because I want to make sure you're comfortable. That we do have a quiz on Thursday of next week. I'll put that in Schoology as well. That's Thursday, November 12th. All right, so now let's look at this one. This one's more like what you see on the AP exam. So they really want to make sure you're using these rules correctly. Like 2 is going to be a product rule, and B is going to be, A is going to be a product rule, and B is going to be a chain rule. So here you're doing 1/2 f of 5, and we're putting 5 in for x because they said so, times g prime 5, plus 1/2. So 1/2 kind of just comes along for the ride here. F prime 5 times g of 5. So you're doing 1/2 times f of 5, which is -4, times g prime 5, which is 10, plus 1/2 times f prime 5, which is of course 2, times g of 5, which is 7. So you should get -20 plus 7, and so we get -13, I believe, if I'm not mistaken. -46, yeah, should be -13. That's that one. For the next one, we got a chain rule going on here. So you're doing f prime of g of 5 times g prime 5. Well, you're doing f prime of g of 5. G of 5 is, of course, 7 straight up. And g prime 5, of course, is 10. And then you're doing f prime of 7, which we have as -1 times 10. We get -10 as our answer for that one. So those are those problems. And then for C, now this is like saying g of x raised to the 3rd power. So you can kind of see like the notation just so you're comfortable with that. G4x would be like that, g of x 4 times, you know. This is another notation thing. If you see this right here, that means the 4th derivative. I don't usually use that notation, but I suppose if you were to see like g like that, that would be like the 2nd derivative. I wouldn't worry too much about that though. But do make sure you know this, right? That's important. So if I do this derivative now, so I do d dx, so you're going to move 3 to the front. Now it'll be g of x squared, and times over the inside, g prime of x. Now, of course, we're plugging in 5, right? So g of 5 squared times g prime of 5. Well, g of 5 is easy. That's 7. And g prime 5 is also easy. That's 10. So you have 3 times 49 times 10. That's 147 times 10. And you get 1470. So that's something you could see on multiple choice on the AP exam, because they just want to make, because you can't really work backwards, you know, you actually really have to know your derivatives to do that problem. For D, now you could do a quotient rule if you want, or you could do f of x raised to -1 power. So it's -1 times f of x raised to -2 power, but then times derivative f prime of x. And we're plugging in 5. And this notation, again, just means y prime at x equals 5, just so you know, like what we see in the end derivative in the calculator. So f of 5, so you're doing -1 over f of 5 squared, because the f of 5 to the negative, fx to -2 is a square on the bottom, and times f prime of 5. And what's f of 5? That's -4. So -1 over 16 times f prime of 5, which is 2. So you get -1/8. Yep, there we go. Okay, and then lastly, for this problem here, so we have said that trig derivatives have to be in radian mode. The reason why is because if you were to actually take this limit, because we use that as part of derivation, I should have mentioned that last time, this only works when h is in radians. So that's the reason why, because we use this notion here. And if I go back to our 3.5 notes, well, they're not filled in. That's awesome. But we use this to help us in our derivation of sine x. And this statement, sine h over h, as h approaches 0, that's going to be true when h is in radians. It doesn't quite work within degrees. And the reason why, let's actually do this derivative in the calculator. So we come over here, we clear. Let's put sine x. And I'll turn it off. And I'm going to go to mode, keep degrees, and go z trig. So you can see it gives me the cosine graph, right? Now, let's switch my mode to degrees and go z trig. Nothing shows up. If I hit trace, it's just kind of weird. It's kind of like, I mean, I guess that you can see why the assumption is radians, because it's trying to do the derivative of sine at these degrees, and it's just basically really small numbers. So it's just kind of a weird situation that's happening there. So that's the reason why, is that when we do this limit as part of our derivation of sine x, as far as derivation for a derivative sine x, the assumption that h is in radians, and that's what gives us that limit. So yeah, in example 10, if I want to take that derivative, I would have to actually change this to radians. So you might remember the conversion to radians. X degrees, you multiply by pi, or 180 degrees. So that's actually what you're going to have to do. Now, if I do my derivative, I'm doing the chain rule. Derivative sine is cosine. So I have cosine of x pi over 180. I can drop the degree symbols. Times the inside, which is pi over 180. And that actually would be correct. So if I were to go back to my calculator now, I want to stick with the degrees, I actually would have to do x times pi over 180. I'll turn that off. and graph in the trig mode. Oh, that would show up. That's weird. I don't know why I did not do that. Oh, that's because also I have times pi over 180. That's the reason why. So that's what's happening actually. So yeah, now we know why it gives us that. That's because what's happening is that by trace, it's taking the cosine multiplied by pi over 180. So that's why we have to assume radian mode. Now, if I were to actually type in the derivative I got here in red, yes, y2 and y3 would be the same. So that's the reason why that's happening. And if I did the second derivative, of course, that'd be negative sign of that junk. And of course, I have to multiply by pi over 180 again, it gets even smaller. So don't worry about that so much. Okay, I think we're all done. You have the Google form to answer after this, and of course, some textbook problems. And I'll see you guys on Tuesday.